So we are going to move on to topic 2.7, which is composition functions. And what I'm going to do is I'm going to do one of the problems from each section. And then if there's multiple problems, then you're going to try them by yourself. I will give you the answer just so you can check it, but I'm not going to do the steps for those problems. And if you have any questions, you can ask me tomorrow. So the first problem that I'm going to do is this one. And basically, evaluate means substitute in. So they're telling us to evaluate with 5. That means your f function is right here. It's 2x minus 3. So wherever you see an x, because this 5 is your x, you're going to substitute it in there. So this is basically going to be 2 times 5 minus 3. That is 10 minus 3, which is going to be 7. And that means f of 5 is 7. When I actually substitute 5 into my f function, my answer will always be 7. Okay, so right now I want you to pause the video and I want you to try these next 3 problems. So for the next 3, those are should be the answers that you should have got once you substitute in and or simplify. So now we're gonna do a little bit more. It's gonna get a little bit more complicated, but it's still pretty easy. They gave us that g of x is 3x plus 1. They said g of 2 is c, and then find g of c. So it's like you're gonna substitute twice. So we're leading up to composite functions and what they actually do. So first thing is we have g's of 2. That means in your g function, you're going to plug in 2 for that x value. So this becomes 3 times 2 plus 1, 6 plus 1, which now you know that g's of 2 is 7. So now you need to find your c function. So now g's of c is going to be wherever you're going to plug in 7 for that c, because you want to find what the c function is. So now you're going to have 3 times that 7 because you're double plugging in. So basically think of it, now you're plugging in this there to find this function, because they're telling you whatever you got for that, that's equal to c. Okay, plus 1. And now you know that the g of c function is going to be 22. That would be your answer. Okay, so now that we have a little bit of how to substitute, remember how to substitute, because technically composition is double substituting, triple substituting, depends on how the function is given to you. Okay, so there are two ways that we can write a composition function. The first one is, let me fix that. It is f of g of x. I know it looks like it spells fog, but that is not a 0 or an O. That is the symbol for composite function. This is the same thing as f g of x. That is the same thing. We read this as f of g of x. That's how we actually say it. One thing that we need to know, working with composition functions, we start on the inside, which is the right, and then if given f of g of x, we evaluate first the g of x function, the inside function, and then we use the answer we get for g of x, and we plug it into the f of x function. So this is what we're going to be doing in the next couple of problems. So evaluating composite functions. So they told us we have two functions. We have f of x equals 3x minus 5, and we have g of x equals 2x plus 1. In this case, it told us that g of x is an actual number. So the first thing we're going to do, there's two ways to doing this, but I think the easiest way to do is first find the actual value of g of x, because they actually gave us one. Then get whatever that answer is, and then substitute it into the f function. So we're going to go g's of 3. We're going to find what the answer for g's of 3 is. That means in the g function, this one right here, wherever I see an x, I'm going to substitute in the 3. And I'm going to simplify that, and I get 7. So now I know that g's of 3 is 7. Now I'm going to use that information, and I'm going to substitute that into my f function. So now I know that f of 7, and now I'm plugging in 7, because this is where I plugged it in. And I'm going to plug into the f function, which is 3 times 7 minus 5. And that should give us that f of 7 is equal to 16. That's my answer. I don't like the equal sign up there. Equal 16. Okay, so I'm going to tell you right now, pause the video and try B and C. And then I'll show you just what the answer was. So if you work this out for B and C, for B you should have got g's of 4 equals 9. That should have been your final answer. And for C you should have got f of 7 equals 16. Okay, so we're going to move on to the next example. We have example 3. I will do A, you can do B, and you can check your answer. So if you notice, they're asking us to use the same equation from the top. So this is my f function, and this is my g function that I'm going to be using for these right here. Okay, so now they don't give us an actual value. So if you notice, they don't give us an actual value for g. So that means we are going to get this g function, this one right here, and we're going to substitute it into the f function. So we're going to have that this is going to be f of 2x plus 1. Okay, so what happens is this this g function becomes my x value. This whole thing becomes my x value for the f function. So now this is what I'm going to substitute into my f function for wherever I see an x. So that now that means I'm going to have 3 times 2x plus 1 minus 5. And I'm going to do my algebra skills. I'm going to distribute. That's going to be 6x plus 3 minus 5. I'm going to combine like terms. And I'm going to get that my f of g of x function is going to be 6x minus 2. That should be my answer. Okay, I'm going to again stop the video or pause. You should pause the video, and I need you to attempt B, and I'll give you the answer in a couple of minutes or seconds. So this should be your final answer that you got. If you have any questions, you could again ask me again tomorrow. Okay, now this time they give us a couple functions. They give us 3. We have h function, the k function, the p function, and the m function. If you notice, we have 2 linear functions, a quadratic and a square root. I feel like you guys should be able to do A now if you actually understood the previous examples. So I'm going to do B. So that's the one I'm going to do, and then I'll just give you the answers for A and C. Okay, so for B, one thing I want you to do, you don't have to write it this way, but sometimes it makes a little bit more sense if you write it as the other way of writing the composition function, which is h m of negative 1. So you basically work this way in. So now if you notice, our x, they gave an actual x value, which is of negative 1. So let's first find m's of negative 1 for that function. And our m function, which is this one, so we're going to have 3 times negative 1 plus 2. We get that m of negative 1 is going to be negative 1. So now that means this value, I'm going to plug it into my h. So now that h of negative 1, and I'm going to plug that into my h formula, which is this one. And I'm going to have that it's going to be 2 times negative 1 minus 3. And I should get that the answer is negative 5. So that means that your h of m of negative 1 is negative 5. Okay, so again, pause the video and try A and C and see if you get the right answer. So A should have been pretty easy. C is not that hard, but it does look more complicated than it really is. You just had to substitute in just like you did before and simplify. So that should have been your answer. Again, if you have any questions, let me know tomorrow. Okay, so on this one, we have a couple of different functions. We have this one that's given us in a graph, which is the f function. Our g function is given us in a table. Our h function is given to us in like a piecewise function. And then a k is a description that we could actually turn into equation, which I'm going to do right now. Since it says that the quadratic function is a horizontal translation of 2 units and then a vertical translation of 3, that means your vertex is 2, -3. That means your k function, if you remember correctly, is going to be, it's a quadratic, so it's going to be squared. It's going to be the opposite of 2, so it's -2, and the same as that, so -3. So that's my actual k function, if you remember stuff from math 2. Okay, so for this one, I'm going to do A, and then you get to do the rest. Well, I'll probably do A and C, maybe. Let's see what happens. Okay, so for A, honestly, you do the same thing. Figure out what g's of 3 is in your function. So that means you're going to look at this function right here. And if you look at g's of 3, where it says x is 3, so if you notice right here, there's no 3's. So that means I can't figure it out. So that means that g's of 3 is not defined. And you're done. It has to be given to you in the formation that was given. So if you cannot find that g's of 3, g's of 4, whatever is in the actual function that they want you to use, then it's not defined. Okay, the last one that I'm going to do, again, is going to be C. And this one, again, I'm going to rewrite it as g's of k of 0. And the first thing I'm going to do is I'm going to work from the inside out. So first thing I'm going to do is going to find what k is a 0 is. So k is a 0. So I'm going to go to my k function. This is my k function. So I'm literally plugging in 0 into that equation. So we're going to have 0 minus 2 squared minus 3. We know that k's of 0 is going to be 1. So now I'm going to substitute that 1, this one right here, back into my g function, or try to find where we're in the g function if there is a 1. If you notice, again, there is no positive 1 here. So that means that g's of 1 is not defined, and they can't do anything else. I just want to say, it does not mean that all of them do not have an answer. It just means those two that I picked did not. Okay, so I say pause the video, and then we're going to work on B, D, E, and F. So for B, that should have been your answer. And for D, E, and F, so for these questions, if you notice, you got an answer for all of these, but then when you got here, you got an answer for k's of 3 and whatever answer you got an answer for h, but when you got to f function, I got a 13, but 13 for the f function, there's no 13, so it was not defined, and that's where I had to stop.